Welcome to session 3 um, regarding session 3 for Python programming language. In this session 3, I'm going to talk about data structures, the very rich functionality that is available in Python under the topic called data structures. We earlier saw in session 1 I talked about quick start examples, introduced you functions and then various basic ideas about Python language, and then in session 2 I talked about objects, lists, and various functionalities of lists. And then in this session 3, I'm going to talk about more about lists and also the list comprehensions, which means functionalities that you can operate on members of lists. I'm going to talk about it. I will also talk about sets, tuples, and dictionaries, which are very powerful in Python. Okay, so let's go ahead. Start with with the data structures. More about lists. That is how to use functions. That is same as methods on the members of lists. Okay, so given a list, you can append members to it. You can append another list to it, or you can extend the list with members of similar types. Okay, so there is a function called append function, and there is also a function called extend. You can insert a list at a very specific place. So lists are mutable. So you are actually inserting it a list in at a very specific place. You can also remove as much as you did insertion. You can also remove. You can also remove what is called pop out, a specific member. Okay. So when you do the pop out, it is it's always a specific indexed place, popping out the specific indexed place, whereas the remove is removing the first item from the list whose value is x. Okay, so there may be multiple valued items, but then you remove the first item in the list when you say remove. But then the pop is specifically removing a position specific item from the list. So let's do quickly some interesting examples. I'm going to do that. So open Python 3.4 GUI, and let's say I have done a little bit earlier. So let's say the words is the list cats and dogs. Okay, and another list L1 birds and bugs. So I can extend the words list with the extend L1 dot extend L1, and when I do that, the cats, dogs, and birds and bugs are added to the cats and dogs as equivalent members. It's not anymore. It's not a sub list, but it is a the cats and dogs are extended with birds and bugs. But then if you do the append L1, you are actually adding this list as a member of the existing list. Okay, as a member of the list. So right now it's a sub list, right? List within a list. I can insert at a specific position, as I said, birds, for example. I'm member birds, I'm inserting it. So when I do that, W1 becomes birds, cats, and dogs. Earlier it was only cats and dogs. I can remove specific member birds. If I do that, then which is in the first, but it can be anywhere else, right? That's what I said. It is the first occurrence will be removed. So now I have cats and dogs. I can pop out specific member 4, for example. There is an error here, so let's go to the right approach. Words.pop 4, that means words.pop is right now words has this, the 4 is this 0 1 2 3 4. This sub list is called the 4. So when you pop out, then it comes out to be birds and bugs, this specific one. You can remove all the members of a list by doing this delete del words left square bracket colon right square bracket. That means members, all members of words. So when you do that, there is nothing there left out. I can reverse, I can sort, I can do all kinds of things. Okay, now what I meant as comprehensions of a list comprehensions, I mean I can work with the members of the list, either mathematical operations or set theoretic operations, or I can do text type operations or truth function operations on the using for loops or anything that anything that is mathematical. I can use it so that I can subset, I can operate on members of the list. That's what list comprehensions means. First one I want to do, before I do that, I want to use a little bit, to talk to you about stacks and queues. Stacks are useful if you want to work with the first in first out type of operations. I'm sorry, first in last in first out type operation. Then you use stacks, last in first out. If you want that kind of operation, then you use stacks. Okay, the keyword is stacks. But if you want to operate like first in first out type operation, then you use queues. Okay, which resembles our real world approach to these keywords, stacks and queues. For example, if you define stacks is equal to the list members 3, 4, 5, I can do the methods to that. So stack.append 6, it adds 6 at the end. If I do again stack.append 7, it adds 7 at the end after 6. So now if you recall stack, it becomes 3, 4, 5, 6, 7. But if you pop, then the last one what you added pops out automatically. Okay, that someone is out of the stack, and then you do pop stack.pop, 6 is out of it, and then again you do stack.pop, 5 is out of it, and then if you recall stack, it has only 3 and 4. On the other hand, queues, in order to do the queues, you don't have to do anything about first. In order to do stacks, you don't have to add any new functions, but in order to do queues, you have to, from collections, class of functions called collections. From that you want to bring an import dq. Okay, so let's define queue to be dq Eric, John, Michael, and then if you say append Terry, it adds at the end. Graham, again it adds further after Terry. And if you do pop left, so first you are trying to do the first in first out, right? The first in was Eric, second in was John, third in was Michael, fourth in was Terry, fifth in was Graham. And if you say q.pop left, then Eric is out of that list. Then remaining is only John, Michael, Terry, and Graham. And if you do again q.pop left, John is out. Now what is left out is Michael, Terry, and Graham. That's what happens when you print, when you recall q, and then it comes out as dq function of Michael, Terry, Graham. See, remember that the q is defined as dq, so it's still the function is attached to that list. Again, list comprehensions, I told you I will talk to you. It is about operating on the members of the list. For example, we can talk about, let's say squares is empty, defined as empty, and then I'm defining squares to be a list containing x squares for x in the range 0 to 10, right? So 10 is not included, 0 to 9 is included. So you will see the values of this one will be 0. If you call in squares, it will come out to be 0, 1, 4, 9, 16, 25, 36, 49, 64, 81, not 100. Okay, but it's a list. Okay, but it is created by the operations x square for with a loop for inside the list in range with the range function. You are able to do that one. So this kind of activity is called list comprehensions, which is more concise and readable, and also it's very efficient. Okay, you can do a lot more complex ones. Here is an example. Create a list with the pair values xy for x in 1, 2, 3, for y in 3, 1, 4, whenever, if x is not equal to y. So for example, x can range 1, 2, 3, and y can also range 3, 1, 4, but the pair xy cannot contain 1, 1 because x cannot be equal to y. So that's what is happening here. 1, 3 is 1 and 3 is included, 1 and 1 is not included, but 1 and 4 is included. That's why the next element is next member is 1, 4. So the list now is all these pairs that are created by this list comprehension activity, functional activity using a for loop. We can do a lot of different different things there with the list members. For example, you can apply different kinds of functions for members of x in some other vector. Okay, you call in that vector, define that vector. Vec is equal to -4, -2, 0, 2, 4, and then you call in that vector for members of vec you can do absolute x as members of a list. That's what happens 42024. Okay, and you can do various functions you can apply. For example, strip functions for a string you can apply. When you strip, when you apply strip, it takes out the blank spaces at the ends of a string. Okay, that's what it is. Strip is all about. So when you apply weapon, fresh fruit is banana with 2 spaces in the front, loganberry with 2 spaces in the front, and passion fruit with 2 spaces in the end. When you do weapon, you are creating a list. When you are creating list, you are talking about acting within a container where the container ends are square brackets. Okay, so weapon.strip function for weapon in fresh fruit. So it cleans up all the things and then puts a new list with banana, no blank in the front, loganberry no blank in the front, blank space in the front, and passion fruit no blank space at the end, but it still keeps the innermost in the middle, the middle blanks. Okay, create a list of tuples like number and square. So first of all, what is a tuple? Tuple is tuples representation is given by single paren, the container with a single paren left and right. Okay, and the thing is that tuples don't, tuples are not mutable versus lists are you can add, subtract, take out, and so on. But in tuples you cannot do. Once you define it, it's defined, and you cannot mute. You cannot. It's not mutable. However, the members of list members of a tuple are mutable. List members of a tuple are mutable. We'll see an example later. Okay. So, for example, you can create a tuple x comma x square for x in the range 0 to 6. Okay, that will come out to be this list: 0 comma 0, 1 comma 1, 2 comma 4, 3 comma 9, 4 comma 16, 5 comma 25. Okay, these pair values are it's not key value pair, but pair values I say, because we are going to use key value pairs later on. So 0 comma 0. So this list, this is a list with tuples. Okay, so so this is how it is. We have created a tuple, 2 tuples like number and square, and which is a collection of tuple members, and but it's a list. Okay, the tuples must be parenthesized, otherwise an error is raised. Okay. Now I can also do another one. Let's work with the nested list comprehensions. Matrix is defined like this. So left square bracket, again left square bracket, 1 2 3 4 5 6 7 8 9 10 11 12. It's a 3 rows 4 columns matrix. And then I'm working on a list comprehension, nested list comprehensions. I'm doing row double square bracket, 2 times it is coming, left parenthesis, left square bracket, row I for row in matrix. Okay, for I in range 0 to 4. Okay, so I can create the same thing in this way. That's the idea. The following list comprehension will transpose rows and columns, but in this case it is 1 comma 5 comma 9, which is basically a transpose of the first column in the matrix, right? 2 comma 6 comma 10, which is the second column transpose, 3 7 11, which is the third column transpose, and 4 8 12, that's the fourth column transposed. But that is happening using the list comprehension. That is a functional, that's an operation that I'm doing on the rows for row in matrix for I in range 1 to 4. Okay, for I in range 1 to 4 for row, I take this row. Okay, for I in range 1 to 4, I take this row I take that 1. For row in matrix, this is the matrix for I in range 1 to 4. So 1 1 5 9 1 5 9, and then 2 6 10 3 7 11 4 8 12. Okay, I can also do transpose function for I in range 4, transpose dot append row I for row in matrix, So you can see this, go through this example as a homework why this works. Otherwise, we can talk about it. Okay. Delete statement, we can delete the whole thing. For example, delete a colon a left square bracket colon right square bracket means all the members of the elements of the list A will be removed. The A becomes empty. That's what happens here. We talked about it. Tuples and sequences. So you define tuples as a members, just a collection of members with comma, right? But it is internally represented with a left parent, single parent, right parent. The container ends are single parent, left parent, and single parent, right parent. Within that, the members of the tuples are separated out by comma. They are also separated out by comma in the list also, but the big difference between this and the list is that it's a square bracket, but here is the single parent, right parent, left parent, right parent. There it is a square bracket, left square bracket, right square bracket as the container ends. So tuples may be also nested. Tuples can also be worked on as a comprehensions. Tuples are immutable and usually contain a heterogeneous sequence of elements that are accessed via unpacking. See, we will talk about unpacking, okay, or indexing, or even by attribute in the case of named tuples. Lists are mutable and their elements are usually homogeneous and are accessed by iterating over the list. The statement t is equal to 1 2 3 4 5 comma 5 4 3 2 1 comma hello string is an example of tuple packing. The values 1 2 3 4 5 comma 5 4 3 2 1 comma and hello are packed together in a tuple. When you do this way, it's packed together. The reverse operation is also possible. You just put x comma y comma z equal to t. This is appropriately called this is called sequence unpacking that works for any sequence on the right hand side. Sequence unpacking requires that there are as many variables on the left as there are elements in the sequence. So let me do one thing here. Okay, the importance of tuples is that I will give you a mathematics example. If you consider x and y axis and a pair value x y axis, x has a very specific meaning and y has a very specific meaning, and changing that. And if you have a collection of xy values, you cannot change that xy values because it has a specific meaning, xy values. Or if you have a not just single pair values, but then it can even be multi-dimensional, okay? Or just a single dimension is also, if you consider those values has specific location, specific meaning, and you cannot change that. So that's why that kind of representation has some meaning in certain calculations. For example, even calendar is another example where you don't want to change the position or mutate the members in the arrangement of a tuple. Okay, so tuples are useful when under some conditions because you want to have a representation of immutable list items, and that's where the tuples are useful. And the tuples, the way tuples are differentiated with the list is that the container edges are simple single bracket, single parenthesis are used to represent the members of the tuples. And members of the tuples are separated out by comma as it happens in the case of lists also, but the edges have a different representation in the case of tuples versus the list. Even though members cannot be members are not mutable in a tuple, if there is a list in a tuple as a member in a tuple, the members of that particular list in a tuple can be is mutable. Okay, that's an exception that I want to bring out. Another data structure that is very powerful and useful is sets. Sets is represented by double parentheses. For example, here basket, it represents a collection of fruits, and then there could be duplicate. That's okay, that's part of the set definitions. But then if you print basket, it will not print in a duplicate way, because set as a basket, it is acceptable to have duplicates, but when you're applying the print function to it, so it doesn't allow the duplicates, okay, by definition. So you can also apply truth functions to the set membership. For example, orange in basket, it's true, but if you say crabgrass in basket, it's false. So that is a in function. In is a verification whether that is true or not, whether orange is in the basket or not. We can do set operations on unique letters from two words. For example, let's say set a word, you put a word, then it parses out all the members of the characters. In this case, abracadabra means, if A is a set, the operation set, the function set is applied to the abracadabra, then the characters of A's are the members of A are the set members of A are A, R, B, C, D, and similarly the set members of B are for B for the string Alakazam is A, L, A, C, L, Z, M. Okay, so if you can do the set theoretical operations here, A minus B, which means all the letters in A but not in B, then A is removed from this, the member A, set member A is removed from the set A, and also R is removed, not R, C is removed because C is available in B. So we have only RDB. Okay, that's why the answer is here RDB. So it's all a set theoretic operations applied to the members of a list. But the list is, because it's a set list, it's a list of set membership. They have a very special container edges, which is double bracket. So I can do A and B means common elements. In this case, A and C, members A and members Z, members C, and A member, all members in A but not in B, but not in both, is the caret symbol is used. All members in A or B but not in both. So that means A and C are removed from the total set union of the sets A and B, which refers to the remaining members, which is R, T, B, M, Z, L. So it's all, again, if you know set theory operations, you can very easily understand this part. You can do list comprehension, like list comprehensions. You can also do set comprehensions for X in abracadabra, if not in ABC. That means members of abracadabra, but remove A, B, C from that. So that refers to R and D only. Okay, that's what it is. So we can do all kinds of functions, operations on the sets also. Now finally, I want to bring out dictionaries for discussion. Dictionary refers to it's a separate type of data structure where we have a key value pairs, similar to a dictionary where we have a word and then the meaning attached to it. Likewise here, key value pairs are collection of key value pairs are considered to be a dictionary basically. So for example, you can just list all keys in the dictionary D. It will just print all the it will just list all the keys, and you can also do apply functions, methods to the dictionaries. Dictionary.key, sorted function sorted left parenthesis D.keys, then it will sort all the members of the keys only and then print it out. Okay, you can also do list D.values within parentheses, then it will just list all the values only. Okay, so for example, here is a dictionary tell, which is defined as a collection of two items, two key value pairs. Jack is assigned a value 4098, Sape is assigned a value 4139, and then you can additionally add member Guido. So you just say tell, that means create that key value pair Guido with the value 4127 in the dictionary tell. So, and then finally, after you do that, if you recall tell, you can see that there are three key value pairs here. Sape is here 4139, Guido is 4127, and Jack is 4098. So you can call in a specific value of Jack also. For example, tell the within quotes Jack, then it prints out the value, its value. Okay, you can also delete members of it. You can list members of keys only. As I said, list tel dot keys. It just gives you the list members as a list, only the keys, and you can do that for values too. And you can sort, as I said earlier, and you can check the truth value also, whether Guido is in tel or not, Jack is in tel or not, and so on. Okay. You can construct dictionaries in 3 ways. One is you create a list and then call it as a dictionary, and then within that list you provide the pair of parenthesized values, the name key and then the value key and then the value key and then the value and so on, but the key should be within quotes. Okay. The other way you can do is you can say again dictionary, but then left paren, it's a function you are applying. When you say dictionary, it's a function, remember that. When you do the dictionary, you can say shape equal to. At this time you don't need to put the quotes for the shape. Shape equal to comma, Guido equal to, Jack equal to. That's another way to define a dictionary. And then finally there is a third way to define a dictionary, which is just to put the double parenthesis, squiggly parenthesis. Sometimes people call it as squiggly parenthesis, and then you equate, put a colon value for each of the keys that should have left quote and right quote. Okay, those are the 3 ways of defining a dictionary. And you can loop over the dictionary key items. You can loop over the keys, or you can loop over the values within a dictionary. And also you can use a for function. You can use you can do list dictionary comprehensions, like as before what we talked about in the case of lists as well as in the case of sets. So those are the important data structures that I want to introduce you, and I encourage you to go over a little bit more details about the comparing sequences and conditions. Learning a little bit more about conditions in the data structures. Okay. So that's all I have on I want to provide you as basics on the data structures, and thank you very much.